look at the numeracy package that you're responsible for completing. This is the numeracy package over here. Your teacher would have shared it with you or printed it for you, or it might be on your course website. It includes all the various numeracy skills that you're in charge of learning for this school year that you'll be using for basically all of your years in science for 10, 11, 12. The idea is that you will go through a variety of notes and videos. The video links are found in this Word document over here, or you might just have lessons from your teachers or a little bit of both. And each numeracy lesson will have a note with it and a link, and you'll go through the note and the link in order to learn that numeracy skill. So you might learn how to do proper SI formatting, measurement and conversions, rounding, solving, significant figures, scientific notation, and graphing. And then when we're done all that, you're going to have different quizzes along the way to make sure that you're on the right path. So we'll have a quiz on format, measurement, and rounding, and solving, significant figures, scientific notation, significant figures together, and then graphing. So this could vary from teacher to teacher. Some teachers might not do quizzes, but they might mark these on tests or other assessments. So again, just pay attention to what your teacher is telling you to make sure you're on the right path with what you need to be doing. So all the videos are there and available for you. We'll quickly go through the package just to show you what it looks like and what it entails. So the first bit of the package is the measurement in SI units. You'll run into a table that shows you how the different measurements are related to each other. And then you'll get to a question where you need to determine what type of quantity each unit lends itself to, or each unit is used for. So for example, you might see grams per mil. You look on the side here and you realize that, well, it's a mass over a volume, so that's going to be a density. You'll also notice, for example, S. So seconds, well, that's going to be time. It's not going to be a mass or length or volume, but a time. So you go through and you select which one you think each unit is going to be used to measure. Then we get to part B. And in part B, you're going to be given different units of measurement, and what you need to do is write their symbols. So for example, for the milligram, it's little m g. You do all that for these, and then you go down and there's some statements that you need to determine what you'd use, what type of unit of measurement you'd use. So for example, if we're looking at the colas, cola is like a soft drink or a pop. You can purchase them in 2 or 3 blank bottles. So you need to figure out what unit you would use. And it makes sense you wouldn't use a meter unit, so any unit of length you probably wouldn't want to use, or a unit of time you wouldn't want to use. So you'd probably be choosing some kind of liter unit. Now, milliliter is very small, so chances are you're not just getting 2 or 3 milliliters bottles. You're probably going to get a liter bottle, so 2 or 3 liter bottles. And you do that for the other statements, and what you can do is compare answers with peers to see if you're on the right track. Next, we get to some conversion practice. So you can write your final answers on the on this sheet here, but I recommend that you take a separate sheet and show your work as you go through this. So for example, you might have to convert the 1,000 milligrams into grams. So what you would do is you would go take a look at your conversion chart to see how the milligram and the gram relate to each other. And we know that if you're trying to go from small to big, so our small unit is a milligram and our big unit is our gram, you need to divide by some factor of 10. When you go look at your conversion chart, you'll notice that the factor of 10 you need to divide by is 10 to the power of 3. And so you'll see that in the video on conversions. And so you're going to divide this 1,000 by 10 to the power of 3, because there's 1,000 milligrams in a gram. The milligrams will cancel out, and you're left with gram in the end. And 1,000 divided by 10 to the power of 3 will be 1 gram. So we have 1 gram over here. Or you could do the move the decimal method, since they're separated by a factor of, since they're different by a factor of 10 to the power of 3, you can grab that decimal and move it to the left 3 times. So 1, 2, 3, and that gives you 1 gram, just like that. And so you proceed in a similar fashion for all of these different units of measurement as you would have seen in the measurement video. So you keep going down, and then you get to scientific notation next. There's a video on that, and you have to write the different numbers in the scientific notation format. So for example, you might have this number here. To write it in scientific notation, you'd count the number of places you need to move in order to get the number 3.940, because this is the um, coefficient for this. You then make an x to show that you're multiplying by 10 to the power of however many spaces you had to move to the left. So 1, 2, 3, 3.940 times 10 to the power of 3. And so that's the scientific notation over here. You keep going down, and you'll have to convert each scientific notation number into the standard notation. So that's the opposite of what you did up here. You're going to do, for example, if I had 6.17 times 10 to the power of 3, I have to move my decimal 3 to the right because of this 3 over here. And so I'll go 1, 2, 3. Here's my new decimal place, and I put a 0 where there's a peak over here. So I have 6,170 as the standard notation for this number over here. And again, you can do the other problems and take a look to see if your answers compare and are appropriate in the answer key that will be posted later on. And same idea here, you're writing numbers in scientific notation in the appropriate way. There's some errors with the formatting here. For example, this needs to be a non-zero digit. This needs to be moved over, and you can do the appropriate modifications as you learn in the video for the scientific notation. Then you continue to move on. There's some scientific notation calculations that you need to do. So for example, you might have this, let's do number 19 here. You do the 6 multiplied by the 4 first, so that gives you 24. Then you do your 10 to the power of 6 times 10 to the power of negative 1. When you do that, that's going to give you 10 to the power of 5 because you're adding your exponents. You do 6 plus minus 1, which is actually the same thing as doing minus 1. And so you get 24 times 10 to the power of 5. But this is not done yet because you need 1 digit before the decimal place, not 2 digits. So you need to move this over 1, and you get 2.4 times 10. And when you move that over 1 to the left, you add 1 to your exponent here, times 10 to the power of 6. And so you're basically just completing these operations for multiplication, and you might see some divisions as well. So make sure you take a look at the video for scientific notation so that you can do these problems here. There's some more practice for scientific notation, writing numbers out in the form of scientific notation, making them in proper scientific notation, taking the numbers out of scientific notation and putting them in standard notation. And there's many examples of that done for you already. And if you find that the video made for you is not up to your standards or is not something you quite understand, you can always search up other videos on YouTube. There's plenty of good ones out there. Then you get to a section on significant digits where you need to identify the number of significant digits. So for example, here, using the significant digit rules from the video, you'd know that there are 1, 2, 3, 4 significant digits. You then continue to scroll down and you'll see some operations with significant digits. So here you'd have to add the significant digits and follow the rule where you need to have the same number of decimal places as the number with the fewest number of decimal places. So make sure you look at that rule. For multiplication, you have to have the same number of significant digits that you would have in the number with the fewest amount of significant digits. So we'll do this example here together. We have 66.0 times 0.031. So 66.0 times 0.031, and we get let me try that one more time. 66.0 times 0.031, and we get 2.046. Now, when we get 2.046, we need to make sure we have the right number of significant figures. So that would be the fewest number of significant figures here. This one here has 3 significant figures. This one here has only 2 significant figures. So we want to round this to have 2 significant figures. So that would be 2.05. And because we have the milliliters multiplied by each other, when you have 2 of the same units multiplied by each other, that becomes milliliters squared. Not when you add, only when you multiply. So the video will end soon. We're going to do a part two of this video just to go through the remainder of the booklet.